Alright, so I also wanted to help you out this week with the section 2. It has to do with quadratic equations. Alright, now a quadratic equation is simply a way to model a certain type of relationship. Okay, and that relationship, if we were to visually look at it, model it visually, okay, it would have a U-type relationship, kind of a U at least. Okay, a parabola it's called. Alright, that's a quadratic relationship. The way that we write this generally, as far as we call it the standard form, or the standard equation with numbers and letters, is the following. Ax squared plus bx plus c, okay, and we want it usually to equal 0. Alright, now notice how there's an x squared and an x. It's different than the equations from the last section where generally speaking it was just a line, okay? And you didn't have a squared variable. Alright, the a, b, and c are just numbers, coefficients, okay? And that moves, if we want to think about it visually, that move this parabola around on the coordinate plane, or sometimes they flip it or make it skinnier or wider, okay? But this relationship, this parabola shape, still stays the same. It still stays a parabola. Alright. So now what this means to you, okay, there's a whole long topic that we could go into with quadratic equations, but what you need to know how to do with this is you need to know how to solve for the x, the possible x's. Now if you notice, this has 2 points that it crosses the x-axis. Okay, and where that comes into play with you, we have been using triangles with Pythagorean theorem where we've had squared terms. You have seen the squared terms. We have a squared plus b squared equals c squared. Okay, so if we ended up doing a Pythagorean theorem problem and we ended up at the end of our problem, let's say with 36 equals c squared, and we had to find out what c was. Okay, what we did is we took the square root of both sides, right? Alright, and then we ended up with 6 equals c. Now, strictly speaking, we haven't entirely gotten all the answers we need, or we could get. Because when you take the square root of 36, it is true that 6 times 6 equals 36, but it's also true that negative 6 times negative 6 equals 36. So there's two answers. Okay, but generally we work with this one when we're talking about measurements, because negative 6, the length of a triangle and the roof or whatever, negative 6 feet doesn't make a lot of sense. Okay. So we only go with the positive term. But for this, you got to realize that, hey, there are going to be two answers, okay, two solutions. Generally speaking, sometimes there's not, but generally speaking, there's two solutions, and you'll have to look for that. So whenever you square something, you have to take the negative solution and the positive solution both. All right, so they give you a couple different ways to go about solving these. This tried and trusty way is to use the quadratic formula, okay? And they do give that to you in the notes of the homework, but I'll give it to you right here as well. Okay, so I just wrote it down here. It's a big old long or ugly looking hairy-carry formula, okay? Now, all you need to remember though is, hey, you figure out what the A is, you figure out what the B is, you figure out what the C is, and then you just plug them in, and then you just punch numbers in your calculator using the order of operations. Okay, and when I say order of operations, this should be a squared. The order of operations, what I mean is you do what's underneath the radical first. Okay, do all that. You square root it, and then remember you have two solutions, so you'll have to write two problems from that point. You have two solutions, and then you can work with the top, the numerator, negative b plus that, or negative b minus that. That's why we have the plus or minus, that it kind of gives you the two solutions already. Okay, and then divide it by the 2 over a will give you a solution for what x is. Okay, so let's do an example. So for instance, if they gave you this problem, I'm going to do it up here so I have enough room. All right, 24x minus x squared equals 8x. Alright, first thing I notice that, hey, this isn't in the standard form. The x squared term isn't coming first. In some of the problems in homework, we're just saying, hey, get it in this form. You don't even have to solve it, just get it in that form. And now you just move the terms around as you need. Okay? So for instance, if you have a, sorry, I'll get rid of that glare. If you have a x squared term second, we got to move it to the front. Okay. Essentially, what we can do is make sure that we keep, excuse me, it's up here. If you notice, it doesn't have a negative term. So it'd be easier for us probably if we made this a positive. Now, how could we make that a positive? Well, we could do it by adding it to both sides. That should be an addition sign. So we end up with 8x plus x squared equals 24x. Okay. Now, these, when we're adding two things, like you could write 3 plus 2 or you could write 2 plus 3. It doesn't matter. You can write them either way. So once we have them both positive, we can just we can use the commutative property and just switch them around. So I can have x squared plus 8x. All right. Now I've got this x squared term by itself. All right. Now I just got to get 0 over on this side. Well, that's easy. I can just subtract out what I have there, and I end up with 0 equals x squared negative, or positive x minus a negative 24x is going to give me a negative 16x. Okay. So now I don't have a plain old c term, but I could write down plus 0 if I wanted. All right. Now I have x squared 16. I match up with my standard form. Okay. The 0 is on the one side, but really I can just switch the 0 around here. Now I have my ax squared term, my bx squared term, and my c term. All right. So now I can plug this into my quadratic formula to find out what x should equal. All right, the number in front of the x, okay, there isn't one shown, but we can always put a 1 there. Okay, so a can be 1. So a is going to equal 1, b is going to equal negative 16, and c is going to equal 0. So then I just plug those into my equation. B's are negative 16, so I have a minus negative 16 plus or minus negative 16 squared minus 4 times 1 times 0, 4, and then all over 2 times 1. Okay. Then I use my order of operations. I do it under the radical first. 1 times 0 is 0 times 4 is 0. So this whole term is 0. Okay. Negative 16 squared, 16 times 16 is a number that is large. I'm going to have to figure that out. That is 256. So I'm going to rewrite this. And by the way, a negative and a negative is a positive. So I'm just going to change that to positive 16. 16 plus or minus, okay, the square root of 256, all right, all over 2 times 1 is 2. All right, now the square root of 256, well, we took 16 times 16, or negative 16 times negative 16 to get 256, so thinking about that backwards, the square root of 256 is going to be 16. Okay, so then we're going to end up with 16 plus or minus 16 all over 2 is going to be our solutions for x. All right. So we got two different things we got to look at here: 16 plus 16 and 16 minus 16. All right, 16 plus 16 is 32 over 2. So one of our solutions is plain old 16. Lots of 16s going on. Okay, so that's one of them. The other one is if we took 16 minus 16 and we'd get 0 over 2. Well, 0 divided by 2 is 0. So our other solution then is x could equal 0. Okay. So in other words, on our line here, our graph, our quadratic formula crosses at 0x and at the x part of 0 and at the x part of 16. Those are the two solutions that it has. Alright, so we solved it using the quadratic formula, which will always work. Okay, that's why I want to show you that first. It is a long, hairy process though, and so there's also some other ways you can solve on some of the equations, okay, some of the quadratic equations that makes it a little quicker, and I wanted to show you that. Okay, the same problem we did here before. Okay, if we get to this point and we realize that, hey, we have an x, at least one x in this term and at least one x in this term, we can factor that x out. Okay, maybe undistribute, you can think about it. Factor that x out and put it up front. That will help us solve this much quicker. So if I take this, I'm going to rewrite it here. So if this is, instead of x squared, I write it as x times x and minus 16 times x. I notice there's a single x that's being multiplied in each of these terms. If I bring that out front, okay, out front, what am I left with? Well, I'm left with 1x minus 16. Okay, that's called factoring it out. Now, in order to kind of check myself, I can redistribute the x. X times x is x squared. X times negative 16 is negative 16x. Okay. All right, now why I did this is because when you think about this, we think of this in terms now of one thing, and this is one thing. What are they doing to each other? Well, they're being multiplied by each other. Okay. All right, well, if we have two things that are being multiplied, okay, and they equal a 0, that means one of those two things has to be 0. Because the only way you're going to get 0 when you're taking multiplication is that one of the factors has to be 0 itself. So in other words, for this to be true, in order for us to solve this, okay, x either has, this term either has to equal 0, or this term has to equal 0. Okay. Well, this is already solved. Okay, and we know that one of the solutions from our quadratic formula was 0. And then to solve for this, all we have to do is add 16 to both sides, and we come up with, hey, x could also be 16 in order for that equation to be solved. All right, so there's two different ways to solve that. I wanted to show you both. You won't, this way won't always work. The quadratic formula will. Let me know if you have any other questions.